Have you ever walked into a room and forgotten why you were there? Or noticed a coincidence so specific it felt scripted? We laugh these off as brain fog or luck. But what if they aren't? What if they are lagging textures or processing errors? Physicists have spent centuries trying to find the bedrock of reality, the solid ground beneath our feet. But the deeper they dig, the less real things look. We aren't finding solid matter. We are finding math. We are finding limits. We are finding code. Today, we aren't talking about science fiction. We are looking at 7 specific anomalies in physics that suggest this universe isn't a place. It's a program. Before we look at the physical evidence, we have to look at the logic. This is the simulation argument. It proposes 3 possibilities. 1. Civilizations go extinct before they can build a simulation of reality. 2. They reach that level of tech but decide not to run simulations for ethical reasons. Or 3. We are almost certainly living in a simulation right now. Think about it. If humans survive another 1,000 years, our computing power will be astronomical. We will simulate our ancestors. If we run millions of these simulations, the odds of you being a real biological human in base reality are 1 in a billion. You are statistically likely to be simulated code, and now, the physics is starting to back up the statistics. Let's start with the resolution of our screen. In a video game, if you zoom in far enough, you see pixels. You see the grid that makes up the image. Our universe has the exact same problem. It's called the Planck length. This is the smallest measurement of length with any meaning. It is incredibly small, but it is not 0. Why does space have a minimum unit? Why isn't space smooth and continuous? In a continuous universe, you could zoom in forever. But in ours, you hit a hard stop. You hit the pixel size. This suggests space-time is discrete, not continuous. It's a grid. And grids are hallmarks of a digital environment, not a natural one. This isn't just a theory. At Fermilab, scientists built the holometer to test this. They wanted to see if they could detect the jitter of the universe's pixelation. It's like looking for the aliasing on a 3D model. If space is pixelated, everything we do is just moving from one coordinate on a grid to another. We aren't moving smoothly. We are teleporting across tiny distances, frame by frame. If the universe was truly organic, there shouldn't be a minimum resolution. The existence of the Planck length is the strongest evidence that we are living in a rendered environment with a limited resolution. Then there is the speed of light. 299,792,458 meters per second. Why that number? Why is there a limit at all? In Newtonian physics, you should be able to push something faster and faster forever if you have enough energy. But relativity says no. There is a hard cap. No information can travel faster than light. In computing terms, this looks suspiciously like a processor speed limit. Every computer has a refresh rate, a maximum speed at which it can process information across the system. If the simulation is running on a processor, information can only propagate as fast as the cycle allows. Consider the causality problem. If you could travel faster than light, you could mess with cause and effect. You could arrive before you left. A computer program crashes if outputs happen before inputs. The speed of light acts as a firewall against causality errors. It prevents the simulation from breaking down. It ensures that event A always happens before event B. It's not a physical law of nature. It's a system constraint to keep the processing logic intact. It keeps the game engine from crashing due to lag. This is where things get spooky. Einstein called it spooky action at a distance. We call it quantum entanglement. If you take two particles and entangle them, they share a state. You can separate them by the entire width of the universe. If you change the spin of one, the other changes instantly. Zero time delay. Faster than light. How is this possible if the speed of light is the limit? In a physical universe, a signal would have to travel from point A to point B. It would take time. But in a simulation, distance is an illusion. Think of a video game map. The character at coordinates 10, 10, and the character at 100, 0 are just variables in the same memory bank. The computer doesn't need to send a signal across the map. It just updates the table. To the computer, there is no distance between those two particles. They are right next to each other in the RAM. Entanglement breaks the rules of physical space because physical space isn't real to the processor. It's just a variable. This phenomenon is arguably the most direct proof that locality is a rendering trick, not a fundamental truth. You've heard of the double slit experiment. When we fire particles, they behave like waves. They exist in a superposition of possibilities. But the moment we measure them, they collapse into a single position. They decide where to be only when we look. This is the observer effect. Why would the universe care if we are watching? Why does it behave differently when it's being recorded? In computing, we call this lazy loading or frustum culling. Video games do not render the whole world at once. That would melt the graphics card. They only render what the player is currently looking at. The stuff behind you, or in the next room, doesn't exist as an image until you turn around. Quantum mechanics suggests our reality works the same way. Matter exists as a probability cloud, a vague dataset, until an observer forces it to render. The universe is saving processing power. It doesn't calculate the specific position of every electron until it absolutely has to. It's optimization. If you change the strength of gravity by a fraction of a percent, stars don't form. If you change the electromagnetic force, atoms fall apart. There are about 20 fundamental constants in physics. If any of them were slightly different, life would be impossible. The universe would be a black void or a chaotic soup. This is the fine-tuning problem. The odds of these numbers lining up perfectly by chance are statistically impossible. It looks like someone set the parameters. Someone adjusted the sliders until the simulation was stable enough to support complex structures. We are living in a Goldilocks algorithm. This one is unsettling. Dr. Sylvester James Gates, a theoretical physicist studying superstring theory, found something strange in the equations. He wasn't looking for it. He was studying adinkras, geometric objects that describe supersymmetry. Deep inside the math, he found computer code. Specifically, he found block linear self-dual error-correcting codes. This is the exact same type of code Claude Shannon invented in the 1940s to prevent data loss in signal transmission. It's the code browsers use to make sure your download doesn't get corrupted. Why would the fundamental equations of the universe contain browser code? Why does reality need error correction? Error correction is for digital data transmission. It's to fix noise in the line. If the fabric of our reality contains code designed to fix transmission errors, it implies that our reality is being transmitted. It implies we are data being streamed from somewhere else. Finding man-made computer algorithms written into the bedrock of physics is like finding a made-in-China sticker on the inside of a natural rock. If the double-slit experiment wasn't weird enough, meet the delayed choice quantum eraser. This experiment suggests that actions taken in the present can change events that happened in the past. It's complicated, but essentially, how we measure a particle now determines what path it took moments ago. It forces the particle to go back in time and rewrite its history to match our current observation. This is retrocausality. In the physical world, this is insane. Time only moves forward. But in a simulation, time is just another variable. It's a reversible process. If the game engine needs to maintain consistency, it can alter the past records in the database to match the current state. It's like a save file being overwritten. The system ensures the narrative stays consistent, even if it has to cheat and edit the logs of what happened previously. The past isn't fixed. It's just data on a hard drive that can be modified to fit the present needs. So, where does that leave us? We have pixelated space, a processing speed limit, optimization through quantum mechanics, error-correcting code in the math, and a timeline that can be edited. The evidence is mounting, but if this is a simulation, who is running it? And more importantly, are we the players? Or are we the NPCs? Maybe it doesn't matter. If the simulation is perfect, the feelings you have, the pain, the joy, the coffee you drank this morning, it's all real enough to you. But next time you see a glitch or a coincidence that feels too perfect, pay attention. It might be the system blinking. If you want to keep exploring the code of reality with us, hit that subscribe button. Leave a comment. Do you think you're real? Or are you just programmed to think you are? Thanks for watching.